Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my programmingforkids.info website and at my programmingforkids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 14 introduces two of Scratch's multimedia inputs, video and microphone. I'll get started. In this challenge, I'll introduce real-time video in Scratch from a computer camera such as a webcam or a laptop camera. I'll create a simple game where when I make enough movement behind the gobo sprite, the sprite will move to a new location on the stage. I won't need the cat. Delete the cat. New sprite. Fantasy. Choose gobo. I'll use some new commands. Go to sensing. To use the video, I'll have to turn it on. I'll want to know when there's motion behind the sprite, and I can adjust how much visibility there is to the video camera on the stage. I'll enable the monitor for this variable. I'll check it. I'll always want to start by turning on the video. I'll go to Events. When a green flag is clicked, turn on the video. I'll move the variable to the middle. I can look at block help for turn on video. Block help. It turns the video camera on. I'll run the program now. Click the green flag. There, I'm visible. My webcam controller is visible now. I'll remove it. I'll move gobo down some, so he's not right in the middle of my face. I can look at help for set video transparency. Go to block help. Set video transparency. It takes a number from 0 to 100. The higher the number, the more transparent the background is, the less you see of it. I can look at block help for video motion. Block help, video motion. It can sense how much motion there is behind a sprite or the stage. I'll only use the video motion behind the sprite. I'll move behind the sprite. You can see the numbers are changing a lot. Getting pretty large too. Stop. Numbers are small. Move some more. A lot of motion. If I move gobo up here, you can see there isn't quite as much motion. I find that simpler backgrounds do better than more complicated backgrounds. Move it back. Easier to see the movement. I can close the help and click on video motion. Only a value of 0. I'll move behind it, click again. Now I get a bigger number, 55, sometimes 0, Not the best of samples. Here, I'll move a lot. 61. No movement. Be very small numbers. I can change the transparency on the stage. If I change it to 0, run it. Now the video isn't masked at all. I can change the value to 100, and the video is gone. I'll leave it like this for a while, a lot less distracting. Scratch is still sensing movement. If I move my hand under where gobo is, the numbers change a lot. You can even see 100 in there. If I don't move, very little change. I always want the video transparency to 50%. Duplicate. I'll attach that. 50%. How would you make code to move the gobo sprite if there was enough movement under it? First, I'll remove video motion from the stage. Sensing. Video motion is not checked. I'll see if it'll still disappear. Oh, good, it does. A little problem with Scratch. I want gobo to be a little smaller. I'll go to Looks. Set size to 75%. Run it. Smaller now. Good. I want a new block to set the new location. More blocks. Make a block. I'll call it New Location. OK. I want to move gobo. Drop that down. Always run this when the green flag is clicked. Go to Motion. Go to. I want to pick a random location. Operators. Pick random. Pick random for X. I'll get one for Y. What'll be a good range for X? Move gobo and drop them. It's about a negative 205. I'll make it a minus 200 to positive 200. Now for the Y value, drop them down about there. Minus 140. That'll work. And a positive 140. Good. See how this works. Click on it. New location. Nice. Like his costume to change, go to Costumes. Gobo has 3 different costumes, different facial expressions. I don't have to choose names. I can also use the costume numbers. Back to Scripts. Duplicate. I can use a random number. Go to Looks. Switch Costume to random number 1 to 3. Now 1, 2, or 3 will be chosen. That'll match the costume number. I'll run it some more. You can see some different faces. When gobo's on the right side of the stage, I'd like gobo to point to the left side instead of facing off stage. I'll go to Control, If Else, go to Operators, less than. If the X position is less than 0, go to Motion, scroll down, X position. If the X position is less than 0, I want to point to the right. Point in direction. 90 degrees should be to the right. It is. I'll duplicate. Else, it's on the right side of the stage. I want to point to the left. I'll see how this works. Run it. Well, he's pointing to the left, but upside down. I need to set the rotation style. Do that at initialization. I can run it right now. Rotation style left-right is good. Try this a few times. Looks good. If there's enough video movement under the gobo sprite, I want it to move to a new position. After it's set its first position, I'll need a loop, forever. Have it keep checking the value of the motion underneath the sprite. I'll use an if, duplicate. I don't need X position. If the movement underneath the sprite is greater than, try 35. I'll move size to initialization. Always want to set the size to 75. Now when the video motion under the sprite is greater than 35, it can set the new location, make the call. More blocks. New location. I'll try it now. Stop. Run with the green flag. It's running now. Move underneath him. And he moves. And moving away quite nicely. Try to catch him. Here it's hard to see the movement in this background. If I have Gobo behind the black shirt, where it's nice and simple black, move detects it immediately. It's harder to see the movement on complicated backgrounds. If you're going to want to play with the video a lot, it'd be helpful to have a simple background behind you. I'll stop the program now. Change the transparency to 100. Now you're not seeing me anymore, and I'll stop it. When this program runs, it's spending a lot of effort checking and checking and checking whether the video motion value is greater than 35. This is called polling or busy wait. The program is polling as fast as it can, checking and checking and checking. It's like checking your phone for new messages thousands of times a second. How many times do you think it would check the video motion value in about 5 seconds? I'll find out how fast it goes on my computer. Data, make a variable, call it count. Okay. Move it to the center. Initialize it to 0. Change the count by 1 every time it goes through the loop. I'll try it. Stop. When I run it, I'll count for about 5 seconds. Watch the counter. Begin. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Stop it. Okay. Turn off transparency. That's over 1 million. In 5 seconds, it checked the value more than 1 million times. That's a lot of effort being spent not getting anything done. This polling is very inefficient. Instead of polling, my program can be told when the video motion is greater than 35. Go to Events. When loudness for now, when video motion greater than 35, duplicate. Don't need this loop now. Move this over. Now when the program runs, count will be set to 0, but count won't be changed. The forever loop is not attached to the handler. And now when the video motion is greater than 35, new location will be called. I'm ready to try this to see if it works. Make sure it's stopped. Run. There we go. And I'll move behind Gobo. There's that. There we go. Easier on a black background. And he's moving all around. I'll stop it. And change the transparency. It's interesting that the video background didn't stop when I clicked on stop. I clicked on set video transparency to 100%. The video went away, but the handler is still running. As I move around here, I can actually get Gobo to still move even though I've stopped the program. You can't see me when I've been moving, but this video motion is still handling events. Earlier, this loop was very busy checking and checking for values. With 1 million checks in about 5 seconds, you can see how it can slow a computer down. Now without the loop and only this handler, my program is idle and responds only when an event occurs. It's much more efficient. It's best to avoid polling when possible. There are times when polling is necessary, but this wasn't one of them. I'm finished with this challenge. I encourage you to play with the program and get comfortable using video motion and understanding the idea of polling versus callback with event handlers. Try changing the program. Try keeping the largest video motion value seen. Try making a real challenging change. Try generating new locations, but only use the new location if it's far enough away from the current location. But above all, have fun with the program. In this challenge, I'll introduce using microphone input into Scratch by making a simple program that shows the loudness on a moving dial like a speedometer. I'll go to Events. So far, I've used my mouse and keyboard to get input into my Scratch program when it's running. I've used mouse clicks on the green flag and on the sprites to get input. I've also used key presses on my keyboard, and I've typed in answers for input into my Scratch programs. With the loudness variable, I can also use microphone loudness for input into my Scratch program. I'll go to block help. On loudness, it shows that it reports the value from 1 to 100 of sounds detected by the computer microphone. I can use these different levels to animate things and to make decisions. I'll close help, and I'll check loudness. I can see the variable now, and you can see it's changing while I'm talking. Loudness runs whether or not I've clicked on the green flag. I'll click on the green flag. I can see the value changing with my voice still. I'll click on the stop sign. Loudness value keeps changing with my voice. I'll generate some sounds with a little 32 piano key keyboard. I'll play a note that sounds like a piano key. Watch the loudness value fade to 0. Started all the way up at 100, made its way back down to 0. One more time. Watch the value. Now I'll use a setting that'll sustain the keys a little longer. I'll play a few notes from Beethoven's Für Elise and watch the values change. One more time. Notice that it can sustain a key and hold the loudness value. I'll hold the key down. Keeps a pretty steady value around 11 or 12. I'll make sure the program is stopped. As the loudness values change, it's difficult to really get an idea of the feeling for the values. These numbers change so quickly, it's hard to see if they're increasing, decreasing, really what's happening with the loudness levels. I can make a loudness meter to show the current loudness. I'll delete the cat. Right-click, delete. There are many ways to visualize this data. This challenge is focused on multimedia input, so I want something simple yet helpful. I'll make a dial like a speedometer on a car with an arrow in a circle. For 0 loudness, the arrow will point at about 10 o'clock on the dial. For 50 loudness, the arrow will point at 12 o'clock. For 100 loudness, the arrow will point at about 2 o'clock. I'll get my dial sprite. I'll go to New Sprite, Things, Button 1. I'll put it in the middle. Go to Motion, go to, make it 0, 0, Events, when the green flag is clicked. I'll click on this, it'll run it now. Dial's in the center. I need my dial pointer. I'll go to New Sprite, Things, Arrow 2. I want the arrow to rotate around the middle. I'll go to Motion, go to, set it to 0, 0, Events, green flag. I'll run it. The arrow's a little bit too big right now, or the dial's a little too small. I want the dial to be a little bit larger. I'll go to Button 1, go to Looks, Set Size. I'll add that on initialization. See what 150% looks like. Try it. That's better, but I don't like the arrow where it is. I move the arrow to 0, 0. Why is the arrow in the middle there? I'd like the end to be in the middle. I'll go to Costumes, Arrow 2. I'll take a look at where Costume Center is. The center of the costume is in the middle of the arrow. The Go To block moves the sprite's costume center to the XY location on the stage. I'd like the center to be here, so this will be in the middle of the dial. I'll move the crosshairs. Now my pointer's in a nice location. I'll go to Scripts. The pointer pivots at the center now, that's good, but what angles to use? I'll go to Motion. It'll be tricky to use turn clockwise and counterclockwise. I'd have to know where I am, whether to turn clockwise or counterclockwise, and then by how much. Relative movement will be very difficult. I'll use point in direction. I'll click on this for 90 degrees. That's where it's at right now. I'll change it to 0, which is up, and negative 90 to the left. It'll be easiest if the dial uses 0 to 100 degrees with 50 at the top. I'll go to my diagram. As I just showed, the pointer points up when the direction is 0, to the left when the direction is minus 90 degrees, and to the right when the direction is 90 degrees. I want loudness 0 to point at negative 50 degrees. I want loudness 50 to point at 0 degrees, and I want loudness 100 to point at positive 50 degrees. It's a simple mapping to change the loudness values to degrees. How do I get 0 to negative 50, 50 to 0, and 100 to 50? How do I change 0 to negative 50? Subtract 50 from the loudness. 0 minus 50 is negative 50. 50 minus 50 is 0. 100 minus 50 is 50. Only need to point in a direction by taking loudness and subtracting 50. Again, a 0 loudness minus 50 gives me negative 50 for degrees. 50 for loudness minus 50 leaves 0 degrees. Loudness of 100 minus 50 leaves 50 for 50 degrees. That's a lot of words for one simple block. That's the challenge sometimes, getting the correct block. I'll go back to Scratch and make this change for the dial's pointer. I'll need a loop for the arrow to keep checking the loudness value. Go to Control, Forever, Point and Direction, go to Operators, minus 50, back to Sensing, Loudness. This will go too fast. Only want to sample about 20 times a second. Control, wait. If I wait for 1/20th of a second, that's 0.05. That'll sample 20 times a second. Before I can run this, I need a few labels of loudness on the dial. Move that up a little bit. Come back. I'll duplicate this. Get rid of these. Now I can try some values. I'll try a loudness of 0. Arrow's pointing at a loudness of 0. I need to put a label there. I'll put it on the backdrop. I'll go to the stage, backdrops. I want text. I'll use the Scratch font. I want to add the number 0. Click again. A little far away. Select it. I'll move it around. See what that looks like. That's good. I'll take a guess on the 50 and the 100. Text. 50. Down maybe a little bit. Try about there. Let's see. That might be pretty good. One more. Try 100. Move it. That looks like about balances with the 0. I'll see if these are close enough. Go back to scripts. Arrow 2. Try a couple more values. Try a loudness value of 50 now. Run it. Pointing nicely at the 50. Try 100. Pointing at the 100. That's good enough for this example. I'll get rid of this now. How can I test this code? I could type in different values in this loop, 0, 50, and 100, and try a few other values in between, but instead of using a loudness variable, I'll create my own variable. Then I'll use the monitor to let me try lots of different values. Data, make a variable. I'll call it my loudness. For the sprite only, okay. Move it over. I'll use it instead of loudness. If I double click on a monitor, it changes to showing only its value. Double click again. I have the variable I also have a handle for adjusting the value. I'll run the program, make sure it's stopped. Now it's running. My loudness is at 0, so the arrow keeps pointing at 0. Now if I grab the handle, I can drag it and the dial moves. Fortunately, the handle goes from 0 up to 100, which is the exact range I want to test. Very handy. So now I've tried all the values pretty much in between. Looks like that's working nicely. I'll stop it. I'm confident that loudness will work correctly. I'll get rid of this, uncheck it, put loudness back in. I've tried out the loop. It worked nicely with my variable. Now I'll use the loudness variable. I'll try these values with the piano. Start the program. You can see my voice changing the dial now. Notice how the arrow gives a little more information than just a bunch of numbers that quickly flash by. I'll play the piano note again. Watch the dial's pointer and see the loudness fade to 0. One more time. Interesting how the dial bounces back and forth as it fades. I'll play a little bit of Beethoven's tune again. One more time. That's working nicely, and the dial helps see more information about the data. I'm finished with this challenge. I hope you'll play with the program and get comfortable with the loudness variable, and, even without a microphone, get comfortable with the dial. Try changing the program. Try creating a high watermark variable. It's a variable that has the highest loudness value seen while the program ran. Try changing the arc for the dial so it covers a larger area. Perhaps something simple like using 200 for the range instead of 100. Then the ratio here would simply be a 1:2 ratio. But above all, have fun with the program. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.